we're going to see a group of logarithms that we want to evaluate without using a calculator. Now, what do you see here? The natural log of e. Now, what is this? Well, it's a logarithm. It's an exponent. So maybe you don't know what it is right away. So why don't we give it a name? We'll say, well, maybe this is x, right? And we want to find out what x is. Well, we know that logarithms are exponents. So x is an exponent. Exponents go on bases. What's the base here? What's the base at natural log? All right, so we're going to try not to write this anymore, but the ln, that's another way of saying log base e. This part right here, that's the same, right? I'm going to circle it, and then I'm going to get rid of it. Those are the same. It's just a different name. Now, this is, what do we have here? ln, that's this part right here, ln of e, so write the e, equals x. Now, the logarithm is the exponent, so that x is going to go on that base. So it's going to look like this. E to the x is e. All right, so what exponent now would you put up here to get e? Yeah, me too. I'd put a 1. All right, so what I'm going to say then is this. That x right here is a 1. So what I'm going to say is ln e is equal to 1. Let's move to 49, and then we'll get the answer to 49, and we'll reflect back to 47, and we'll see a general trend here. So we want the natural log of e to the 5th. So maybe we don't know what it is right away, so we call it x. E to the natural log of e to the 5th, some number x. Now, what is this ln? That ln we know, right? In our heads, we think this, all right? So I don't have to write it every time. Of e to the 5th is x. But that logarithm is the exponent. So that x goes as an exponent on that base right there. So x becomes an exponent right here. So it's going to be e to the x equals e to the 5. And you can see this, right? You got the bases equal. The x has to be a 5. So x has to be a 5. So then we're just going to claim then that natural log of e to the 5th is 5. Now, look at the result in 47, and look at the result in 49. Come back up here to the tops of each original problem. The natural log of e. Now, isn't this really e to the 1st? Sure it is. Natural log of e to the 1st, natural log of e to the 5th. So what'd you get for the e to the 1st? You got a 1. You just got the exponent. What'd you get for this one? Natural log of e to the 5th. You just got 5, the exponent. Now, there's a reason for this. Remember that we said that these two functions, the exponential function and the log function, log base 10, log base e, whatever log it is, these are inverses of each other. That means one of them undoes the effect of the other. So in general now, if I looked at something like this, if I looked at the natural log of e to the x, here's what's happening. Okay, now I'm going to do a little evolution thing down here. I'm going to start with x, right? Here's our variable. I'm going to start with x. Then what do? I exponentiate it, which means I raise it, I make it a power, but it becomes the exponent. So this is e to the x, all right? So I started with x, I raised e to that power, and then I'm going to undo what I just did. So then I undo what I just did. So where am I? I'm right back at x. So now just in general, if you have this, if you have the log base b of b to the x, where these two bases match, and that's what we have here, right? Look at this. E to the x. What's the base here? E. So the bases match, you just get the exponent. So when you have the bases match, like we do down here, the log base b of b to the x, what you get out of here is x. Problem number 51 turns out to be exactly this one right here. What's the natural log of e to the x? So you look through, right? I mean, we know this now. When the bases match, this base is e, this base is e. You just get the exponent. So this, we know, just to be x. But if you wanted to write it out, log base e of e to the x, then you're thinking, okay, what exponent do I have to put on that e to get e to the x. Well, you would have to put x. In 53, we want, now this is the common log of 10,000. So what is the base here? This base is 10. So, you know, I don't write it every time, but I'm thinking this is at least in my head. What exponent am I going to put on 10 to get to 10,000? Well, I know this. 10 to the first, that's only 10. 10 squared, that's 100. 10 cubed, that's 1,000, right? The exponent tells you how many zeros there are. 10 to the fourth, well, there we go. I've got 10,000. So what do you know? You know now that the log of 10,000, that is equal to 4. And I'm going to do 55 here. 55, what we want in 55 is the natural log of 1 over e cubed. Now, that 1 over e cubed, I'm going to rewrite like this. Natural log of e to the negative 3, right? I'm going to bring that up by changing the sign of the exponent. And now, I've got this situation right here. I've got the natural log and the e, right? So the natural log of e to the x is negative 3. So this just turns out to be negative 3. Let's see what we can do with this 57. Now it's the log of the square root of 1,000. Now none of our logarithm properties have radicals in them. So let's get rid of the radical, convert it to a fractional exponent. This is going to be the log base 10, right? I might as well write it, of what? 1,000 to the 1/2. I'm going to have to get a little bit creative here. I've got to get this to match that. So this is going to be the log base 10 of, now what do you know about 1,000 that has a base of 10? Okay, well I know this. I'll take 10 to the third, and then that's to the 1/2, right? So a little creativity here. I got to get that 1,000 in terms of that base, so it matches that. And now what do you do with this? When you have a power raised to a power, you multiply those exponents. So this becomes the log base 10 of 10 to the 3 times 1/2. This is going to be the log base 10 of 10 to the 3/2. And now I've got this situation right here. The bases match, and I just get the exponent. Right, the bases match. That was the whole idea of getting that 1,000 up here in terms of the 10, because the bases match. So what's the exponent? 3/2. So this whole thing here is equal to 3/2.